Hello guys, Assalamu alaikum. I'm Shubra Ahmed from Exam Essentials. Today we will solve the October 2024 Physics Unit 1 question paper. So without any further wasting of time, let's get started. So in our first question they have give which of the following units is equivalent to the watt. We all know the only thing of which unit is watt is power. We know power's unit is watt. So okay, we can write down the formula. Power is equals to work done divided by time taken. So the unit of work done is joule and the unit of time is seconds. So we can say joule s minus 1 is going to be the unit. So this is going to be our correct answer. Moving forward to the question number 2, they have written which of the following table gives two vector quantities. We know for something to be a vector quantity there needs to have both magnitude and direction. So if you look at this A, acceleration is a vector quantity as well as the weight is a vector quantity. So our answer is going to be A. Though displacement is a vector quantity, but kinetic energy is not a vector quantity. Energies are always scalar quantities. Here, velocity is a vector quantity, but strain is not a vector quantity. Young modulus is a vector quantity, but mass is not a vector quantity. Mass is a scalar quantity, and they have asked us to figure out two vector quantities. So we are done with question number 2 as well. Now moving forward to the question number 3, what they have written is the displacement time graph for a person running a race is shown. So this is the displacement time graph, and we know the gradient of this graph, the gradient will give us the velocity, because gradient means displacement divided by time. When you divide displacement by time, you get the velocity. So gradient will give us the velocity. Which of the following gives the average velocity of the person? So they have asked us to find the average velocity. For the average velocity, we need to take the whole distance and the whole time period. So let's go. Area between the curve and the x-axis from 0 hours to 4 hours. So they are talking about the area. So we know that area means we have to multiply displacement due time. So this is not going to give us the velocity. Velocity has been given by dividing the displacement with time, but area means multiplying the two x and y axis. So this is not our answer. Gradient of a tangent. No, gradient is going to give us the velocity, but this is the instantaneous velocity of a particular point, not the average velocity. So this is not going to be our answer. Of 4 hours means that it will give the instantaneous velocity at that moment. This is our instantaneous velocity at 4 hours. Gradient of a tangent at 2 hours. Now this will also give us the instantaneous velocity of 2 hours. Displacement at 4 hours divided by time of 4 hours. Yes, this is going to be giving us our average velocity. Why this will give us our average velocity? Because we are taking the whole 4 hours and the whole 4 hours displacement along with the time 4 hours. So this is going to be our answer. Alright, so moving forward to the question number 4, what they have written is the photograph shows a cable car hanging from a cable. The cable car is in equilibrium. Okay, equilibrium means all the forces are balanced. Okay, which of the following forms are Newton's third law of pair forces with the weight of the cable car? We know weight is one force, and they have asked us to find out the other force which will act as Newton's third law pair forces. We all know for the two forces to be Newton's third law pair forces, the forces should act on different bodies, and the forces act on same bodies but of different, the forces should be of different. Alright, so what they have here asked us is which of the following is a Newton's third law pair forces, and the one force will be weight. So let's say there is the weight, and one confusion that I wanna clear today is we always mess up saying that weight and normal reaction force, they are third law pair forces. No, they are first law pair forces. They are not third law pair forces. Why they are not third law pair forces? because for something or for the two forces to be third law pair forces, they should act on different bodies. They should be acting on different bodies. This is the first criteria. But weight is acting on the man. Weight means pull. The weight means push on earth from, sorry, my bad, push on man from earth, and the normal action force means pull on man from earth. So both the forces are acting on the same bodies. The forces are acting on the man, the forces are acting on the object. But the Newton's third law pair forces means the forces should act on different bodies. Forces should act on different bodies, and the forces should be of the same type. But weight is a pull force. This is pull of the earth on man, and this is the push of the earth from on man. So both of them are acting on man, and they are of different forces. So they are not normal action force. Normal contact force is not the Newton's third law pair forces. So we can omit this answer. This is not going to be our answer. Alright, we know air resistance cannot be a Newton's third law pair forces because they are not on different directions. Not on different directions. Okay. So our answer is going to be B. The gravitational pull of the cable car on the earth. So it is acting on the earth, and the weight is acting on the cable. So they are acting on different bodies, and they are of the same forces because weight is a gravitational pull of the earth on the cable, and this is of the cable on the earth. So this is our Newton's third law pair forces, and upthrust is also not our answer. Why upthrust is not our answer? Because they are not of the same type or magnitude. So we are done with question number 4 as well. Now moving forward to the question number 5. What they have written is a box slide down a slope at constant speed. Weight and resistive forces acts on the box. Okay, let's draw the box right now. Here it is, the box. So when a box is sliding down here, the weight, this is the weight that is acting. So this weight, this is the horizontal component of the weight right here. So this horizontal component of the weight must balance out this resistive force. This is the friction, let's say this friction or this resistive force. This friction must be equal to the horizontal component of the weight for this box to slide down with a constant speed. What does constant speed means? No acceleration, no resultant force. So for this box to slide down at a constant speed, there is no resultant force. When there is no resultant force, that means the friction and the horizontal component of the weight must be equal. This is the vertical component of the weight. Alright, if you want to know about this equilibrium and vector components and vector diagrams with an inclined slope, and especially if you learn about this inclined slope part, please go through my YouTube channel and scroll down a little bit. You will find a vector diagrams video which I will put down in the description link as well. You can watch them down. Okay, so which of the following is the reason why the speed of the box is constant? So let's read the first one. The component of the weight parallel to the slope. So this is the slope, and this component of the weight is parallel, is equal to the sum of the resistive force. So resistive force is friction, so this is going to be our answer. We can easily omit all the other parts. Alright, moving forward to the question number 6 right now. What they have written here is a person stands on a moving staircase. Okay, moving staircase increase the gravitational potential energy. Let's say this is the staircase and here it is the person. he'll be going upward. Okay, so increases the gravitational potential energy. So when someone gains a height, he also gains gravitational potential energy. So the moving staircase increases the gravitational potential energy of the person by 5,000 joule in a time of 42 seconds. Okay, they have given us the efficiency as 0.63 and they have asked us to find the power of input. We know the formula of efficiency is power output divided by power input. So they have given us the efficiency as 0.63, which is equals to the power output will be, this is our power output because it gained this amount of gravitational potential energy. So this is our 5,000 and we can easily find out the power input. So our power input will be 5,000 divided by 0.63. Alright, actually this is not our power input, my bad, this is our total energy. We have to figure out the power output later on. This is our total energy. So now we can figure out the total energy. This is our total energy. So now we will find out the power using this total energy divided by the time that they have provided us with. So this is going to be 5,000 divided by 0.63 divided by 42, which means 5,000 divided by 0.63 into 42. So our answer is going to be C. Okay, so we are done with them. And this is not going to be our power output because they haven't calculated the power part yet. They have just given us the time. That means this is our total energy and this is our useful energy. And after finding out the energy, we will be using that in order to find out the power by multiplying the energy by the given time taken. Alright, so moving forward to the question number 7 right now. A student applies a force to stretch a thin metal wire. Which of the following describes the wire at the elastic limit? At the elastic limits, okay, the wire is elastically deformed. This is the answer because at the elastic limit, the wire is elastically deformed and the plastic deformation occurs beyond the elastic limit. So this is not our answer. And this is given as maximum extension. Maximum extension means beyond plastic limit. And this is during the plastic section. It happens at the plastic section. And the wire snaps. When does the wire snaps? At the braking system. So this is not our answer as well. Alright, so moving forward to the question number 8 right now. What they have put us here is a student used a wooden bat to hit a stationary ball of mass m. As he hit the ball, as it is second stationary, that means the initial velocity is 0. As the bat hits the ball, the momentum of the bat decreases by del p. The ball then moves with the velocity v. Okay, let's write it down. We know del p is equals to mv minus mu, or it can be written as mv minus u as well. Alright, so we know del p is equals to m v minus 0, which means del p is equals to mv. This is our first equation. Okay, the student then uses the ball to hit a stationary ball of mass 3m. So this has a greater mass than the previous mass. The momentum of the bat decreases by del 2p. It decreases double the times it decreased in this part, which was only del p. So let's write it down right here. 2 del p is equals to, the mass is 3m v minus u. So 2 del p, or you can write it down as 2 mv because del p means mv. So we are writing this right here, the 2mv is equals to 3m, we can write it down this v as x, 3mx, because this u is 0 and this is our x. Let's keep it down as x. So this is our 3mx, so x comes as 2mv by 3m. So m goes down and we are left with 2 by 3v. So this is going to be our answer. Now moving forward to the question number 9, they have said two boats A and B are pulling a ship. Each boat is attached to the ship by a rope as shown. Okay, this is force A and this is force B. We can see that if this is taken as like this, for force A, this is going to be FA cos 31, because this is with the angle, because this line is with the angle, so this is going to be FA cos 31. And for this is going to be, for this B, this is going to be FB cos 27. So basically these two will be added as they are in the same direction and in the same line, so we can say C is the correct answer. Okay, as they have asked us to find the forward components of the total force, that's why we have taken this line as the forward force. Now moving forward to the question number 10. In this question they have said a student puts a piece of wood on top of a cylinder. He stands out on the wood with his feet at distance x and y from the cylinder. Okay, so this is going to be our pivot right here. Okay, the weight of the student is W. Diagram shows the force of each acting on the wood. The wood is horizontal and in equilibrium. As it is in equilibrium, the total clockwise moment is going to be total anti-clockwise moment. The weight of the wood is negligible. They have asked to find an expression for W. Okay, we know we can take this cylinder as a pivot. Taking the cylinder as the pivot. Alright, then we know this is our anti-clockwise moment and this is our clockwise moment. So this is going to be force into x. F into x is equals to, this is W minus F into this perpendicular direction, which is y. W minus F into y. So they have asked to find the expression for W. So it will be W minus F is equals to Fx by y. We have divided this y with the Fx. And now this W is going to be Fx by y plus F. So our answer will be this one. Sorry, my bad. So this is our correct answer. Not this, not this, and not this. Okay, so we are done with all the 10 questions. Now I have a very good things to say to you guys, that I'm starting a high impact crash course for the May 2025 candidates, where we will solve all the question papers from January 2020 to October 24 before you guys sit for the exam, as well as the January 2025 paper as well, so you guys can take a very good preparation before the exam. And we will also review the whole syllabus from the scratch. No matter how much problems you have in your basics, you guys will get a lot of recorded videos of mine which will help you guys to recover your weakness. And you guys will also be doing live classes with me. You guys will get around 12 live classes per month, and I will review the whole syllabus with you guys. So don't worry at all and join our May 2025 crash course. And if you want to join our crash course, we'll be providing our Facebook page link on the description. Please go through the description and join us or message us at our Facebook page, or you can also join us or message us via any other link as well. If you don't have Facebook, please comment down below. I will provide you with my personal ways to contact me. And you guys can, and the other, for the January 2025 candidates who are going to give the exam within the next 7 days, I have prepared a 7 days question paper sprint week for the candidates, where we will solve and all the problems from the January 2020 till October 24 for the students in these 7 days for the physics unit 1 and unit 4 candidates and all the chemistry, biology and maths candidates. But the students who will have the unit 2, unit 4 and unit 5, 6 and unit 3 exams after 15th January, they will get 2 weeks question for sprint preparation, so they will be able to ameliorate their preparation. So kindly join our course and let me know in the description. You guys can look after the description box to join us, or you guys can comment down below. So have a good day guys, and if you wanna solve more and more question papers with me and review the syllabus with me with my detailed notes, and you wanna get my frequently asked questions, modified worksheets and notes, then please do message at our Facebook page. Have a good day guys. So let's start section B. Alright, so let's start section B, question number 11. Two forces acts on an object. The forces are perpendicular as shown. They are perpendicular. One is 1200 Newton and the other one is 2300 Newton. Okay. They have access to magnitude of the resultant force. So they have access to find the magnitude of this resultant force. So using a scaled vector diagram, they have asked us to use a scaled vector diagram. Using a scaled vector diagram, you can easily calculate these values using Pythagoras theorem, but this is not going to be that easy. They have asked us to find using scaled vector diagram. So here what we have taken is, what we have done right here is, they have given us 1200 Newton and 2300 Newtons. So we have taken 200 Newton as 1 centimeter. If 200 Newton is 1 centimeter, then 1200 Newton becomes 6 centimeter. And the 2300 Newtons becomes 11.5 centimeters. So now we will plot these two diagrams. Come on, let's do it. So for this 2300 Newton, we have taken 11.5 centimeters right here. This is an 11.5 centimeter graph. Okay, this is 11.5 centimeter. You have to use a scale in order to draw them. And for this 1200 Newton, we have taken 6 centimeters. Here you go, our 6 centimeters. This is our 6 centimeter. And after drawing them two, we have to draw a line like this. This is the resultant force line, and we have to calculate the length of this line using our scale. And when I measured that length using my scale, I figured out that this length comes as 13 centimeter. So as we have taken 1 centimeter as 200 Newton, then I multiplied this 13 with 200 and I got 2600 Newton, which is my resultant force. So this is how you guys will have to complete this question number 11 right here. And this is not that difficult to actually answer this question. It's easy, but using the scaled vector diagram is difficult because a lot of students face a lot of problems while solving scaled vector diagrams. That's why I've actually made that thing easier for you guys. Let's dive into the question number 12. A student has a spring of length 0.18 meter. Okay, this is the length of the spring, and the spring has a stiffness constant of 25 Newton meter. So this is our K value. The student applies a force of 7 Newton to stretch the spring. So 7 Newton is our force, and they have access to find the new length of the spring. So when you provide or you apply a force to a spring, it will extend like. So we have a formula called F is equals to K into del X. So we have got the K as 20, sorry, my bad. So we have K as 25 Newton meter minus 1 and the force as 7.0 Newton. So now we have to make the del X as the subject of the equation and divide 7 by 25. So this is our del X value. And now they have access to find the new length of the spring. So the new length is the original length plus the change in length. This is the change in length and this is the original length 0.18. So the new length will be the original length plus the extension. This is the extension. So new length is equals to 7/25 plus 0.18 meter. So the answer will be 0.46 meter. So here you can write it down as 0.46 meter. Moving on to the question number 13. A bicycle pedal is connected to a circular chain ring. So this is our pedal which is connected to this chain ring. This is the chain ring by a lever. So this is the lever. A person of weight W stands on the pedal. So this is actually the rickshaw that we always see in Asian countries. Now it is available in United States as well. The lever is at an angle of theta to the horizontal. So this is the horizontal and it is at an angle. This lever is at an angle. Determine the moment of W So they have asked us to determine the moment of W about the pivot point when theta is 24 degree. So they have said that this theta value is 24 degree and they have asked us to find out the moment of W, and this is our pivot. Alright, so we know moment is equals to force into perpendicular distance from the pivot. Let's write down the formula. Moment is equals to force into perpendicular distance from the pivot. I have written the force like this. Please don't write like this on your exam day. I'm just writing it to make you guys understand in a very short period of time. So moment is equals to force into perpendicular distance from pivot. So this weight is our force. We will write it down as weight into, they have said perpendicular distance. As this weight is completely vertical, we need a horizontal distance from the pivot. But this distance of the lever is not horizontal, it is an angle. So we have to take the horizontal component of this lever. The horizontal component will be, this is 24 degree and it is 0.21. The length of the lever is 0.21. So it will be 0.21 cos 24 degree. We cannot take this 0.21 because it is at an angle, but we can take the horizontal component of 0.21. We can take the horizontal component of length of lever because the weight is completely vertical. So we will take 0.21 into cos 24 degree, and here the weight was 580. So the overall value comes as 110 Newton meter. So we are done. Moving forward to the part B of this question, they have said a chain ring exerts a force on the chain. So this is the chain ring which exerts a force on this chain. F is proportional to the moment of weight about the pivot. So this is very important. This line is really important. They have said this F is proportional to the moment of W about the pivot. Okay, so these two things are proportional. We can say force is directly proportional to weight. So when the force increases, the weight increases. When the weight decreases, the force decreases. And this is not only the weight, this is the moment of weight. Okay, this is very important. Moment of weight. So when the force increases, the moment of weight increases. All right. So explain how F changes as theta increases from 0 to 90 degree. So how will this F respond if this theta value increases from 0 to a bigger value? Okay, let's say they have mentioned actually it is 90 degree, not a bigger value. You can also say that when it increases from 0 degree to 90 degree. So how this force will behave if that increases? As they have said, force is really proportional to the moment of W. So we know the moment of W is dependent on this cos value, right? The moment of W is dependent on this cos value. So they have says as the theta value increases, they have says this theta value will increase. So if the theta value increases, if this theta value increases, how will the moment react? So let's go forward and look at that. We know one thing, that is when cos is, let's say when cos is 30, cos 30, if you calculate it, cos 30 is 0.86, but cos 60 is equals to 0.5. So what we have seen right here is, as the theta value increases, okay, as theta value increases, the cos theta decreases. As this theta value increases, as this cos theta increases, this overall theta value decreases. So we can mention this as our first part. So if this cos theta decreases, if this overall cos theta decreases, let's say in this moment, if this cos theta decreases, then definitely our moment will also decrease, because moment and cos theta value is proportional. And if our moment of weight decreases, then our force will definitely decrease, because they are directly proportional. So we can also mention that thing. The second part will be, so the moment of W about the pivot decreases as the cos theta value decreases, which also makes the force to decrease as they are directly proportional. So we are basically done with question number 13. Okay, so let's solve the question number 14 now. They have said a student clamped a meter rule so that it was vertical. She dropped a ball from rest near the top of the meter rule as shown. The strobe emits flashes of light. The time interval between flashes is constant. Okay, so the time interval means, what does this time interval means? This is a very important thing. The time interval means, let's say, we will make you guys understand in the next part. The student photographed the ball using a strobe lighting. The ball can be seen at different heights in the photograph. So this is the different flashes of light. Okay, for each flash of light, the student determined the distance fallen by the wall, and then she took one photograph using a strobe app and the other one using a laboratory strobe. Okay, the time interval between flashes was the same for the strobe and for the meter rule. So this is very important. These two lines are very important. So the time interval for both the strobe wave and the laboratory was the same. So what does this time interval means? The time interval between flashes means the time gap between two consecutive flashes of light. Let's say this one and this one. These are the two consecutive flashes of light, right? So the time gap between these two flashes is known as the time interval. Okay. Each flash of light from the laboratory strobe has a smaller duration than each flash from the mobile phone. Okay, there is a difference between them. There is a difference which we will do not using the red pen. So the duration of light. Now they are talking about the duration of light. So duration of light means the duration of one single flash. The duration of flash means the duration for one single flash. This is the difference between time interval and duration. The time interval is same. The difference of time between these two consecutive flashes is same. But for the mobile phone, the duration is higher than the duration for the laboratory strobe. they have written as this. Laboratory strobe has a smaller duration. That means it flashes for a longer period of time when it is captured using mobile phone, and it flashes for a smaller amount of time compared to the mobile phone when it is captured using a laboratory strobe. So they have made those distinctions between them. Okay, in the later part what they have said is explain. They have asked us to explain how the smaller duration of each flash from the laboratory strobe affected the uncertainty in the measurement of the distance fallen. So how this smaller duration from the laboratory strobe affected the uncertainty value. This is what they have asked. So let's say if the duration is small, what will happen? Let's say if an object is moving right here. If an object is moving right from here and I am from this position providing a light. This is a light, and this light will have a bigger duration. If it has a bigger duration, then I will be able to capture the whole motion of the car going from this position, right? I will be able to capture the motion of the car for a longer period of time. And if the duration is small, then I will be able to capture a smaller motion of the car. Let's say if the duration was bigger, I would have been able to capture 5-meter distance that this car will travel. Let's say from here to here it will travel 5 meter. I will be able to capture 5 meter because the duration is greater, because the flash duration is greater. So the flash will be on for a longer period of time, so I will be able to capture the whole period of passage or whole period of motion of the car. But if the duration is smaller, let's say it will flash for 2 seconds. So when it will flash for 2 seconds, it will turn off very quickly. So I won't be able to capture the whole 5-meter period of the car. So I will be able to capture 3 meter. So the image will be smaller. For smaller durations, the image will be smaller. And as this image is smaller, its uncertainty value will be less as well, because it is smaller and it is more precise. So that's how we will write those down. So let's write down. We can write each image of the ball would be smaller. Don't write the car, because I have used the car in order to make you guys understand. Each image of the ball would be smaller using the laboratory strobe. This is our first point. And they have asked us about the uncertainty. And what will happen to the uncertainty? The uncertainty will be less because the image is smaller and you can capture it with more precision. So the uncertainty will be less. So these are the 2 points that you guys can use. In short, if I make these guys understand to you to a much better extent, will be smaller duration. They have asked about the smaller duration. Smaller duration means smaller image. Why smaller image? Because the object moves less during the flash, resulting in a sharper, more compact image. And smaller duration also means less uncertainty. Why? Because the object's position is captured more precisely, because it has less time to move during the flash. So these are the more explanations that I can provide you guys. You can write those explanations in this part of your question paper to make you guys become more accommodated with those things. And also you can use those extra notes before revising for the exam. All right. So the student recorded the distance as fallen by the ball corresponding to the value t. Explained by a graph of s against t gives a straight line. Okay, this is a very small. So when the ball was falling, we didn't apply any force into it, right? So its initial velocity will be 0. It was in a free fall, right? Its initial velocity will be 0. So if we want to calculate the time, we have to use the formula s is equals to ut plus half a t square. This is the formula, right? S is equals to ut plus half a t square. This is the Sovart equation that we can use rather than the other ones. So if the initial velocity becomes 0, then we can also say s is equals to half a t squared. And now if something needs to be a straight line, we have to compare it with y is equals to mx plus c, right? Y is equals to mx plus c is something that should be the equation of a straight line. So this is also quite similar to the y is equals to mx plus c. We can say s is equals to half at squared. This is our y and this t is our x. Sorry, this is our x. And this half a is our m. So y is equals to mx. This is a straight equation of a straight line. We can also make them understand using that. Now we can write one more thing, that is s is proportional to t squared. This s is proportional to t squared. So the gradient of graph is constant. We can also replace this a by g because it will be in free fall, right? You can replace that a by g as well. That will not be an issue. So this is how you guys should be proceeding this answer. All right. So let's move forward to the question number 2. In this part, they have said a student plotted a graph of s against t square as shown. It is a straight line and it is directly proportional. That's why the gradient has been given like this. They have asked us to find out the acceleration of free fall. So they have asked us to find the acceleration of free fall. So how will we find the acceleration of free fall? We know the formula was s is equals to half at squared. Formula was s is equals to half at squared, and this is our y is equals to mx. So we have to find this acceleration from here, and we know very well that this half a value is our m. So if we can find out the gradient from this graph, then we can use that gradient to find the a value. So let's figure out the gradient right now from here. So in order to find the gradient, we can actually turn this like this, and this will be our another value. This is our another value. These are the two values using which we can figure out our gradient. So let's calculate how much it is. So this is 0.30 right here, as it is 0.3. This value is 0.3, right? That's why it is 0.3. And here this is our del s is equals to 0.3, and our del t squared is equals to 0.06. So these are the two values. So if we y is equals to mx, so if have to find out the m, m is equals to y divided by x. So y is our del s divided by t squared. So our del s was 0.30 divided by 0.06. So our m is equals to 5 meter per second squared. Okay, so we know half a is equals to m, right? Half a is equals to m, and we know m is equals to 5. So half a is equals to 5 and a is equals to 10 meter per second squared. So this is our acceleration value. We are done with the question number 14 as well. Before jumping on to the question number 15, now let's have a look at the courses that we are providing for you guys, especially for the January 2025 candidates and May 2025 candidates. And the details will soon pop up in the screen. Please have a go at the courses. If you want to join our course, then please message us on our Facebook page, Exam Essentials, or you guys can comment down below. Okay, so heading into the question number 15. In a high jump competition, athletes jump over a bar. An athlete has a weight of 680 newtons. So this is the weight of the athlete. The athlete exerts a force of 890 newton on the ground. So here the athlete is exerting a force on the ground, right? The athlete is exerting a force on the ground. So according to Newton's third law, the ground will also exert an equal and opposite force on the athlete, which is our Newton's third law, right? This is our Newton's third law. So explain why the athlete accelerates upward. So why is the athlete is going to accelerate upward is the question right now. Why the athlete accelerates upwards? So the thing is, the first of all we will write this Newton's third law part. We will write according to Newton's we will write the ground exerts an equal and opposite force on the athlete of 890 Newton according to Newton's third law. I have written N3, but please don't write N3 in your exam, write Newton's third law. So here this is the upward force, right? This is our upward force. We can write the weight of 680 Newton is our downward force, which is smaller than the 890 Newton upward force. So there is a resultant force upward. So the athlete accelerates upwards. So this is the perfect answer for this question. Okay, so this 890 Newton was exerted by the ground to the athlete. So the ground is this, and it exerted that force to the man in this direction. So the upward force is greater than the weight, which is the downward force. So this is why our answer will be like this. So we are done with the question A part. So moving forward to the B part, what they have said is the athlete move horizontal as it passes over the bar. The kinetic energy has been given as 490, and they have asked us to find the horizontal speed. They basically asked to show us this. So we know the formula of kinetic energy is equals to half mv squared. So we know the kinetic energy is 4.9, half is half, and we have to find out the v square. But for v square we have to find out the mass. They have given us the weight, right? 680 Newton. So using the weight we can figure out the mass. 680 is equals to mass into 9.81. So the mass comes as, the mass will be 69.3 kg. So here we will use that 69.3. So our v square, if we make v square the subject, the v comes as 3.436 ms minus 1, which can be written as 3.44 into 3 significant figures. All right, so as the question suggests 3 significant figure, we have written the answer in 3 significant figure as well. Moving forward to the next question, they have said after passing over the bar, the athlete moves through a vertical distance of this. So as they have mentioned vertical distance, they have mentioned the vertical distance, and they have asked us to calculate the velocity of the athlete. They have asked to find out the velocity of the athlete. So previously we have found out the horizontal velocity or the horizontal speed. So the horizontal speed is this. The horizontal speed was 3.44, and as it has a horizontal velocity, it will definitely have a vertical velocity. The vertical velocity we will have to find, and after finding out the vertical velocity, they didn't ask us to find the vertical velocity, they have asked us to find the velocity. So this is the actual v, this was our vh, and we have to calculate the vertical velocity is equals to. So calculate the vertical velocity, we can use the vertical distance. We can use the vertical distance. We know, if we write it down like this, we know that the boy or the athlete went up and then came down over the bar. Let's say here it was the bar was right here, so it go up and then came down. So here at the top its velocity is 0, right? The final velocity is 0, and we have to find out the initial velocity. Initial velocity is the vertical velocity, initial vertical velocity. Okay, and we know the displacement as 1.4 meter. So here the displacement is 1.4 meter. They have given us the displacement. Okay, so we can use the formula v square is equals to u square plus 2as. The final velocity is 0. U square is what we have to find, plus 2 into acceleration. We know the acceleration is 9.81. As it is a double motion, we are taking acceleration as negative. We know we always take acceleration negative when it is a double motion or something is going up. We take the acceleration negative. As we're only calculating about this part, we're only discussing about this part, the upward motion. When we consider the upward motion, we take acceleration as negative, and the displacement as 1.4. So here the u value will be 5.24 ms minus 1. So this is our u value. So this is the value of vertical velocity as 5.24. If we take a vector triangle right now, if we draw a vector triangle, let's draw it like this. So here it was 3.44, and this is our v, and this was our 5.24. So using the Pythagoras theorem, we can figure out this v value, which will come as v is equals to root over 3.44 square plus 5.24 squared. The answer will be 6.27 ms minus 1. So this is our magnitude of velocity, but we have to find the angle from the vertical. So this is the angle which we have to find out, and we can easily find that out using the tan theta. We know tan theta is equals to 3.44 divided by 5.24. So theta value is 33.3 degree. Please don't write them like this. Try to exemplify them by writing all of those things. I am trying to make you guys understand in a very short period of time. That's why I'm writing like this. Please don't write the u like this. Please show the workings. Okay, so we are done with the question number 15. Now heading towards the question number 16 right now. Alright, so let's start the question number 16. A simple hydrometer is a cylinder with mass at one end. So this is a hydrometer which has a mass at one end. The cylinder floats vertically in a liquid. It is a liquid. It is immersed in liquid. The diameter of the hydrometer is x. A scale on the side of the hydrometer shows the vertical position of the hydrometer in the liquid. So there is a scale which tells us how much length is under the water and how much is above the water. Okay. A student placed the hydrometer in a sample of pure water. Complete the free body force diagram to show the forces acting on a hydrometer when floating in water at equilibrium. Okay, so as they have mentioned that it is floating, we can say the upthrust and the weight. The only two forces acting on the hydrometer is the upthrust and the weight. So both of them must be equal, as it is floating and it is in equilibrium. Equilibrium means all the forces are balanced. So let's write it down. This is our upthrust force, which must be equal to the weight. So the upthrust is equals to the weight. All right, so this is what we have to draw, and we can also mention that the upthrust is equals to weight. You actually don't need to write that, but I have still written that in order to make you guys understand in a much better fashion, nothing else. So this is what the explanation looks like. So let's move forward to the question number B. So that the student placed the hydrometer in a sample of seawater. So this is our seawater in which they have placed the hydrometer. Seawater is more dense than pure water, so here the density is greater. Here the density is greater. It has more dense. It is more dense. It has more density. At equilibrium, the vertical position of the meter was higher in the seawater than in the pure water. So the hydrometer was in a higher position than it was in pure water when it was in seawater. When it was in seawater, it was at higher position. Explain why the vertical position of the meter was higher in the seawater. So this was the question. The thing is, we know both of them have the same weight, right? Both the hydrometer have the same weight. They didn't mention anything that they have different weights, so we can assume that they have the same weights. So we can write upthrust is the weight of the fluid. So this is 1 mark question which you can write in every fluid mechanics questions. This is 1 free mark which you have to write. Upthrust is the weight of the fluid displaced. Upthrust is the weight of the fluid displaced. This is the first line that you can write. Now our second line will be, yes, we know upthrust is the weight of the fluid displaced. So as both of them have the same weight, they will displace the same amount of weight or same weight of water. They will displace same weight of water as both of the hydrometers have the same weight. So we can write that the upthrust remains the same. The upthrust remains the same for both the water. Now we know that the upthrust remains the same for both the water. So according to the equation, we know upthrust is equals to rho Vg. So if we know it has greater density, so if the density increases and the upthrust must remains constant. The upthrust is constant for both of them. If the density increases, then G is also constant. So for keeping this upthrust constant, the V value must decrease. The V value must decrease. So we can write it down in our own words that as the density decreases, the upthrust is the same, so the volume must decrease. My bad, it is not decreasing, it is increasing actually. The density increases. We can also mention density is greater in seawater. So we are done with them. We can mention one thing, why the upthrust remains the same. This is a very important thing. Why does the upthrust remains the same? It is an extra note which I am giving to you guys. You guys don't need to write that in your exam paper. I'm just giving you that in order to make you guys understand. We know upthrust is same as weight remains unchanged. All right. So now heading towards the question number 16.2, they have said calculate the change in the vertical position of the hydrometer, okay, when moved from pure water to seawater. So how much it changed its position, what means how much it moved upward. This is what they have asked us to find. They have given us the weight of the hydrometer, density of the pure water, density of seawater, and x. This is the x of x is equals to 1.23. X is this value. This is the diameter of the hydrometer. They have given us the diameter of the hydrometer. Okay, don't mess this up thinking that it is the change in vertical position or it is the vertical position. Okay, they have given us the weight. So in order to, we can use this weight value to calculate the mass of the hydrometer. So mass is equals to, we know weight is equals to mg, so mass is equals to 0.324, which is weight divided by 9.81. The value comes as 0.333. Sorry, 0.33 only, not 333. 0.33 kg. Now as we have get the mass and we know the density, so we can calculate the amount of water displaced, the volume of water displaced. Volume of water displaced is equals to, we know density is equals to mass by volume. So volume is equals to mass by density. Mass is 0.33 divided by 997 kg. So this is 0.033. So the value comes as 3.31 into 10 to the power minus 5 meter cube. Okay, so we have calculated the volume of pure water displaced. All right, so now up to this part it was very easy to figure out all those things. Now we have to figure out the cross-sectional area. We have to figure out the cross-sectional area of the hydrometer. So the cross-sectional area is equals to pi d square by 4 for the hydrometer. Okay, so here pi into 1.23 divided by 100, as it is in centimeter we have to convert it into meter, squared divided by 4, which comes as 1.882 into 10 to the power minus 4 m minus 2. So we have successfully figured out the cross-sectional area. As we have figured out the cross-sectional area, now we can figure out the height of the pure water. Let's figure out the height of the pure water. For the height of the pure water, we can take upthrust is equals to, we know, rho Vg, but here the V becomes cross-sectional area into height. We know volume can also be written as cross-sectional area into height, so we will take it down as cross-sectional area into height. So the formula becomes PAHG. This is the formula right now. Okay, so upthrust is equals to 0.324, which we have got before. This is the weight. We know weight of the hydrometer is equals to the upthrust. So 0.324 is equals to 997, which is the density in pure water, into this cross sectional area, which we have figured out before, 1.882 into 10 to the power minus 4 into the height into 9.81. So the height will come as 0.279 meter. So we have successfully figured out the height. Now let's figure out the height for the sea water. So the sea water height will be the same formula, upthrust is equals to PAHG. So our density is 1025. Here is the density of the sea water, into the cross sectional area, which is 1.882 into 10 to the power minus 4, which we have figured out before, into the height into 9.81. So now we can figure out the height. So the height is equals to 0.271 meter. So this is the height when seawater, and this is the height when pure water. So the change in the height, change in vertical height, is equals to 0.271 minus 0.279 minus 0.271, which is equals to 8 millimeter, though this value comes as 0.0008, which can be converted into 0.8. It can be converted into 8 millimeter. You can write it down as 8 millimeter, or even you can write it down as 0.0008. But in the mark scheme, they have written it as 8 millimeter because, yeah, you can write it down in any other ways as well, not an issue. Both of them are actually correct. So this is the question number, this is the end of the question number 16. I hope you guys have understood, and the most important thing that you guys have to understand is the upthrust is equals to weight of the hydrometer. Upthrust is equals to weight. This is one assumption that we have to take right here. We have taken 0.324 as the weight of hydrometer. We know the upthrust is equals to the weight because both of them are floating and they are in equilibrium. That's why we have taken upthrust is equals to weight. Done. So in the question number 17, they have said a student is about to do a bungee jump from a high bridge. The student is attached to the bridge by an elastic rope. Okay, the student jumps from the bridge and initially accelerates. Okay, he accelerates. The diagram shows how the students at 3 different positions during the bungee jump. Okay, it is position A, B and C. In position A, they have said the distance fallen by the student is equal to the original length of the rope. So the original length of the rope is equals to the distance fallen by the student. Okay, all right. And in position B, they have said the student is in equilibrium. Okay, when something is in equilibrium, the forces are balanced. The forces are balanced, and the two forces that is acting on this student is his weight and the tension force from the rope, right? So at B, the tension is equals to the weight. Okay, and the rope has maximum extension at point C, so the tension will be greater than the weight right here. So for position C, the weight will be like this and the tension will be greater than the weight. Here the tension is greater than the weight, here the tension is equals to the weight at position B. So what happens at the position A? The distance fallen by student is equals to the original length of the rope. Okay, so let's go forward and write them. So what they have asked is explain how the acceleration of the student changes as she moves from position A to position C. So they have asked us to calculate the accelerations, and the air resistance is said to be negligible. All right, we can understand them. Okay, so when the original length of the rope, at that point the distance fallen by the student is equal to the original length of the rope. So it has just fallen towards downward and the distance fallen by the student is equal to the original length of the rope. So here tension is greater than the weight. Sorry, my bad. The weight is greater than the tension, because as he didn't exceeded the original length of the rope, so the tension is less than the weight. So our weight is greater than the tension till right here. Okay. So what we can write for this is, for this question we can write, let's go downward. We can write at A, the weight is greater than the tension. So why is the weight greater than the tension? Because the distance fallen by the student is still equal to the original length of the rope. So when it started falling from here, if it was right here, let's say if it was right here, the only force that is acting right here is its weight, because the tension will start working when the student will exceed the original length of the rope. At that time it will stretch the length. It will stretch the length of the rope. When you stretch the length of the rope, only at that time the tension starts working. So it is equal at the moment. So the weight is greater than the tension. So we can write the weight is greater than the tension. So when the weight is greater than the tension, our weight is a downward force, right? So if the downward force is greater, then the resultant force is always downward. So we can say that the resultant force is downward, and they have asked to mention the acceleration, and the acceleration is also downward. So we are done with our first 2 points. So the tension is increasing, right? As it is going downward, the tension is increasing between the as it is going downward, as the loop is extending, the rope is extending, the tension is increasing, right? The tension is increasing. So when the tension is increasing, let's say if the tension is increasing, then the resultant force is downward, right? The resultant force is downward. Weight is, if the tension is increasing, then the weight is decreasing. So if the weight is decreasing, when the tension increases, the weight decreases. If the weight decreases, then the resultant force, which is downward, is also decreasing, right? So we can mention that the tension is increasing, and hence the resultant force is decreasing. So the acceleration also decreases. Alright, so now we can talk about between A and B. Now at B, this was for at A. Now we can write for B part. For B part, we know the tension is equals to the weight. So at B, we have to mention tension becomes equal to the weight, because they have mentioned that it is in equilibrium. So when something is in equilibrium, the forces are balanced. So the tension and weight is balanced, they are equal. So when they are equal, there is no resultant force, no acceleration. And no acceleration. So at point C, what will happen is, at point C, now the tension is greater than the weight, because it has reached the maximum length of the rope. One thing you can understand is, when the length of the rope is increasing, when the length of rope increases, the tension also increases. That's why at point A, the length from this position to increase till this position, right? That's why the tension is increasing, and hence the resultant force is decreasing. From A to B, this length is increasing. So when the length is increasing, the resultant force is decreasing, because when the tension increases, when the length increases, the tension increases. If the tension increases, the weight decreases. So when the weight is lesser than the tension, when the actually the weight doesn't decrease, weight is constant, but when the tension increases and becomes more than the weight, at that time the resultant force also decreases. All right. So now about point C, we know the tension is greater than the weight. We can mention that tension is greater we can mention that the tension is greater than the weight, and the resultant force now is upward. Why the resultant force is upward? Because tension is the greater force, tension is the upward force, as it is greater, so the resultant force will be upward. The downward force is smaller, so the resultant force will be upward. The resultant force is now upward, and hence the skydiver decelerates. Why does it decelerate? Because the resultant force is in the opposite direction to its motion. The bungee jumper is going downward, but its resultant force is acting upward. So the resultant force is acting in the opposite direction to its direction of motion. That's why it is decelerating. So these are all the 6 points that you have to write in order to answer this question. And these A study questions are really important. These questions more or less repeat in every year. In exam essentials, we have customized all the 6 marks questions and frequently asked questions, and all the moment related, simple harmonic, fluid mechanics and stress strain young modulus. These are some chapters in which more or less every year questions are repeated, including projectile motion as well. So in exam essentials, we have concluded and we have taken the decision to carry out 7 days question paper sprint, which will start from January 1st. You guys can join that batch, as you guys have exam on 8th January. So you guys can go through my whole 7 days exam sprint, where we will solve all the question papers from May 2020 to October 24. And I will take 3 Unit 1 mocks as well for you guys. And for Unit 2, Unit 3, Unit 4, Unit 5, Unit 6, physics, chemistry, biology, maths, all of them, you guys can join. For Unit 1, you guys will get 7 days, as the Unit 2 exam is on 15th or 14th January. So you guys will get more than 1 week. So you guys will get 2 weeks to take the preparation under me. You can message our Facebook page, Edexcel Exam Essentials, to take your preparation to the next level. Hopefully you guys will join our question paper solving sessions. Now in the B part, what they have mentioned is, the bridge is above a river. The student will reach the river if the rope stretches to a length of 35 meters. So this is the length which is required for the student to reach the river. The student has a mass of 65, length of rope is this. So this 70-meter length of rope needs to extend to 35 meters in order for the student to reach the river. The rope behaves like a spring with a stiffness constant. Okay, they have given us whether the river during the jump will reach or not. They've asked us to figure that out. So let's figure that out. You guys can think for this for 2 minutes. I will give you guys 1 minute to think about it, because it's very important to be able to visualize things by yourself. Let me know guys in the comment below if you have been able to figure that out. Okay, so let's start right now. I will start by myself. So the required value is, we can value the required value for the student to reach the river is, we know they have given us the constant, stiffness constant. We can use that. We can use F is equals to K into del X. Here the force is equals to, you can figure out the force. We know K into K is equals to 250, and del X is 35 minus 17. This is the change in length minus. So this force value comes as 4500 Newton. But we are not concerned about that force, because we will figure out the elastic potential energy of the rope, because they have asked us about the rope. So let's find out the elastic potential energy, which comes as half into 4500 into del X, which is 35 minus 17. So you guys might have a question right now that why did I found or figure out that elastic potential energy? They didn't ask us to find the elastic potential energy. So the thing is, this is the required energy. And what energy does the student have? The student has a mass which they have given us. They have given us the original length of the rope. Okay, so the student has a mass of 65 kg, right? And the rope is 17. The total length of the rope is 35 meter. This is the total length of the rope. So if the student reaches it, what will be his gravitational potential energy? Let's find that out. No, sorry, my bad. It's the elastic potential energy. So here the potential energy will be is equals to 65 into 9.81. This mass into gravity into height. The height is 35. So when the student will be 35 meter with the length of the rope, it will be 35 meter. Let's say the length of the rope is 35 meter. So when the student is right here carrying the rope, it has a GP, right? So I have found out that GP 65 into 9.8 into 335, which comes as 22300 joule. So this is the available energy of the student. And this is the required energy. So as the required energy, as we can mention as 40500 is greater than 22300. So the student won't reach the river. Okay, because in order to reach the river, student has to have this amount of elastic potential energy, but the student only have this small amount of potential energy, which is his mass is 65, his acceleration, and its height, which is 35 only. The bridge is above a river, so above the river 35 meter above the river, it is only does have 22,300 joule of energy. But in order to reach the river, it requires this amount of energy. So the student doesn't have that amount of energy to reach the river. So we are done with the question number 18. Now moving forward to the question number 19 right now. This is the question number 18. In question number 18, what they have said is, some spider form silk in long thin threads to catch flying insects. Okay, Darwin's bark spider can produce very long threads. As students investigated the properties of these threads. So actually this type of questions, this extra information are not that required. The stress has been given as 4.3 MPa. The radius has been given as this, and they have access to find the force. We know the formula, stress is equals to force per unit area. So they have given us to find out the force, and they have given us the stress and the area. So what we can do is we can do 4.3. This is megapascal. This is megapascal. That means 4.3 into 10 to the power 6. 4.3 into 10 to the power 6. You will multiply megapascal into 10 to the power 6 to calculate it into pascal. Into this area is equals to pi r square, pi into 1.9 into 10 to the power 6 squared. Sorry, my bad, only this part will be squared, not the other part. So here the force value comes as 4.88 into 10 to the power minus 5 Newton. So this is our overall force value. Sorry, my bad. I'm writing it again. Stress is equal to force per unit area. So 4.3 into 10 to the power 6 into pi into 0.9 into 10 to the power minus 6 squared is equal to 4.88 into 10 to the power minus 5. This is the force values. And don't forget to write the Newton part. Alright. We are done with question number 18A. Now moving forward to the question number 18B, they have asked us to find out They have given us the Young modulus and stress and a thread of length. So this is the length. Okay, when they have given us about Young modulus, what I will first do is I will write the formula of Young modulus. E is equals to stress by strain. All right, so the formula is force per unit area into L by del x. This is the formula of Young modulus, right? So what they have given is they have given us the length, they have given us the Young modulus, they have given us this value, they have given us the strain, this is the strain value, and they have asked us to find the length of this thread. So this is the del x value which they have asked us to find, length of this thread when stretched. So this is the del x. There is a distinction between this line and this line. They have said here thread of length, and they have said in the second part length of this thread when stretched. When stretched means it's about the del x part. So let's write it down here. We know the Young modulus is 8.70 into 10 to the power 9. It is gigapascal. Gigapascal is 10 to the power 9 is equals to, this strain is 300 into 10 to the power 6, which is megapascal, into the length, which is 25, divided by the del x. This whole force per unit area is our stress. So here the del x will be 0.86 meter. So now the total length will be, they have said length of the stretch when stretched. So after stretch means the previous thread length plus the extension length, which is 25.0 plus 0.86, which comes as 25.8 meter. So we are done with it as well. Moving forward to the question number C right now. This is a very easy question, but it seemed really difficult for the students to solve. My previous year students also asked me that this question was really difficult for them. So in this part, they have said a sketch graph shows the stress strain relationship for the spider silk up to its limit of proportionality. Add a line to the sketch graph to show the stress strain relationship for the steel up to its limit of proportionality. Okay, so what they have given us is, this is the stress strain, right? And they have given us the Young modulus. So we know that Young modulus is equals to stress divided by strain. So the gradient of, if you divide stress divided by strain, we will get the Young modulus. So Young modulus is the gradient of this strain graph. So this is the gradient. One thing that is important is this Young modulus is the gradient of this stress strain graph. So as it has a smaller value and as it has a bigger value, that means steel has a greater gradient. So it is a greater gradient. As its gradient is greater, it will be more steeper than the spider silk, and its value here written is 350. So what we can do right now is we can put a value here as 350 and then draw a much steeper line like this. So this is the steeper line, this is steeper, this is more steeper than this one because of the gradient being bigger, so the steeper more. All right, so the second part is done as well. Moving forward to the next part, they have said a sample of the steel has the same shape, length and cross sectional area as a sample of the spider silk. Okay, steel and spider silk have the same shape, length, cross sectional area. Each sample is stretched to its limit of proportionality. Okay, explain which sample has a greater elastic strain energy. So we all know stress into strain gives us elastic strain energy. So the area under these two graphs, will give us our elastic strain energy. This area and this area, including that. So this area will give us elastic strain energy, and this area will give us the elastic strain energy for the this whole area. Okay, so what do you think, which has the greater area? Obviously this one has a greater area. So it will have greater elastic strain energy. So let's go and write it down there. We can write elastic strain energy is proportional to the area under the graph. Then area under the graph of steel is less than the area under the graph for spider silk. So spider silk has a greater strain energy. Please don't forget to write elastic, greater elastic strain energy. Done. We are done with this whole paper. And now we are only left with the question number 19. Then we'll be done with the whole paper. Okay, so let's solve the question number 19 right now. In the question 19, they have said a deep sea diver is a person who swims at great depths below the surface of the sea. Okay, the first question they have said is state the condition for Stokes law to be applied. Okay, we know for the Stokes law to be applied, the object must flow with laminar flow. The object must be traveling at slow speeds. This is the first point, and the second point will be the object must be small and spherical. These are two easy marks that you guys should memorize these 2 points, because this is more or less repeated in every physics unit for exam. The object must be small and spherical. Alright, so we are done with it. And the point B, they have said the mass accelerated to terminal velocity as it fell to the bottom of the sea. Okay, a mass is reaching terminal velocity as it is falling to the bottom of the sea. At terminal velocity, the mass was 25 meter in 0.3 seconds. Okay, there was a difference of 4.6 Newton between the weight of the mass and the upthrust on the mass. Okay, so they have said is there's a difference of 4.6 Newton between weight and upthrust. Okay, so as something is falling, its weight needs to be greater than the upthrust. So we can say from here that weight minus upthrust is equals to 4.6 Newton, right? They have said the difference between the weight of the mass and the upthrust on the mass is 4.6. That's why we have written weight minus upthrust is equals to 4.6 Newton. And we all know that weight is equals to upthrust plus drag when something is falling downward. When something is falling downward, this is the weight and here is the upthrust and here is the drag. Both of them are acting upward and the weight is acting downward. So weight minus upthrust is equals to drag. So we can say 4.6 Newton is our drag. Drag is equals to 4.6 Newton. Done and dusted. Now they have given us the volume. We can use that volume to figure out the 4 by 3 pi r cube. We know volume is equals to 4 by 3 pi r cube. We can use this volume to calculate the radius. So 45 is equals to 4 by 3 into pi r cube. So the radius is equals to 0.022 meter. As we have successfully figured out the radius, now we know it fell 25 meter on this time. So we know speed is equals to distance divided by time taken. We know distance is 25 and the time is 0.36, so the speed will be 69.4 ms minus 1. We have got our speed, we have got our radius. Now what we can do is, we know drag is equals to 6 pi r eta v. So 6 into pi into the radius, which is 0.022 that we have figured out before, into this eta value 1.2 into 10 to the power minus 3 into the volume that we have figured out before was 69.4. Okay, they have given us the volume. Sorry, my bad, it will be 45, not that value. 6 pi r eta into 69.4 ms minus 1, this is our velocity, not volume, my bad, is equals to 0.0347 Newton. So this drag value is way smaller than this drag value, so we can say the Stokes law is not applied. 0.347 Newton is less than 4.6 Newton. So Stokes law not applied, does not apply is more appropriate. All right. So moving forward to the question number B right now, the graph shows the vertical velocity of the diver varied during a dive. Okay, the diver was at the surface of the sea at 0 seconds. Okay, at 0 seconds it was at the surface of the sea. So this is when he was moving upward, and it is when it is moving downward. As this is velocity is a vector quantity and it shows the direction. Okay, explain how the graph could be used to show the diver reached the surface of the sea. Okay, whether it reached the surface of the sea or not. So to figure out whether it reached the surface of the sea, we know that it reached the bottom of the sea. Let's say this is the bottom of the sea. Whether he reached the bottom of the sea or not depends on, actually whether he reached the surface of the sea depends on, they have given us the time at 22 seconds. Okay, we know speed is equals to distance divided by time, and distance is equals to speed into time. So this VT graph, the area under this VT graph will give us the distance, this area under the VT graph. If the area under this A1 graph is equals to the area under the A2 graph, then both of the distances will be same. So we can say it reached the bottom, it also reached the surface of the sea, because these two distances are going to be equal. Okay, these two distances are equal. So let's write it down right here. We can write area under or above the curve gives the displacement. Don't write distance, because here the velocity is a vector quantity, we have to mention displacement, as there is double motion upward and downward. So this is our first point. The second point will be area above the curve must be equal to the area under the curve, as it as it shows that the diver traveled equal distance down and up. Alright, so moving to the at the end of the question paper, this is the last question. Determine the vertical acceleration of diver at 70 seconds. Okay, this when there is a 70 second, this is the 70 seconds. We have to figure out the vertical acceleration at that moment. So we have the VT graph, so we can draw a gradient in order to find the, we know acceleration is equals to v by t. So if you find the gradient, it means v by t, we will get the acceleration. So the gradient of VT graph gives us the acceleration. So let's draw a line right here. So this is the line. So here this value is approximately 48, this value is 100, and here it is approximately this is approximately 0.08, because the upper value gives us the upper value gives us this is 0.1, so this is 0.8, 0.08 or anything like that. You can take it a little further as well, not an issue, because it is 0.05, so you can also take it as 0.08. So our gradient will be 0.60. This is the 60 value, which is 0.60 minus this value, which is 0.08, divide by this value, which is 48, minus this 100 value, which comes as minus 0.01 ms minus 2. So this is our acceleration. So we can say acceleration is equals to minus 0.01 ms minus 2. So we are done with solving.